Okay, question 22, very challenging again. An alkene reacts with hot concentrated acidified potassium manganate to produce a single organic product as shown. Okay, so it's asking you to work back and try to find out what this alkene was, and these are the various options, based on what the formula of the product is. Okay, so what we're talking about here is an oxidation of alkenes. And in order to get this right, you need to understand some fundamental concepts. First of all, you need to know you are dealing with what happens to these carbons, the carbons involved with the double bonds. So these carbons in option C, these carbons in option D. And you need to remember your rules. We have various different rules depending on how many hydrogens that each of those carbons is bonded to. Okay, so I'm just going to quickly copy in the rules now. Okay, so here are our rules. If you've got a carbon bonded to 2 hydrogens, okay, you're going to produce a molecule of carbon dioxide. If you've got a carbon bonded to 1 hydrogen and 1 alkyl group, and remember each of these carbons here in this chain are going to be considered as alkyl groups. So if you've got 1 hydrogen and 1 alkyl group, you're going to produce a carboxylic acid. I'm just going to write Ca, because I'm writing with a mouse and it's inconvenient. If you've got a carbon bonded to 2 alkyl groups, then you're going to produce a ketone. Now those rules are fundamental. It's worth understanding exactly why, but more than anything, it's worth remembering those rules. It will get you a very long way. Okay? So now we're just going to look at one example. I'm going to draw in a few more of the bonds here, okay? If we look at this carbon, we've got to remember that there'd be a hydrogen there, wouldn't there? Okay, so in this case, this carbon, the carbon involved in the double bond, is bonded to 1 hydrogen and effectively to 1 alkyl group. Because remember, that would be CH2 there. Okay. In other words, this carbon right here is going to produce a carboxylic acid. Okay. If we look at this carbon here. So this carbon, remembering that this would effectively be a methyl group here, and that takes up all our bonds. So this carbon is bonded to 2 alkyl groups. So in this case, this carbon here is going to produce a ketone. So we've got this side here, this carbon forming a ketone, and then we've got this carbon here forming essentially a carboxylic acid. In other words, you break this double bond essentially, and you replace it with either your carboxylic acid group or your ketone group, okay? And hopefully that's going to get us to the answer. Right, the answer is D, and I'm just going to work through the actual answer, and then you can go ahead and work through the other options, and you'll see then why they can't be correct, okay? Before I do that, let's just try and make things a bit clearer, and let's draw this out, showing more of what's going on with the atoms involved. Okay, so I've drawn it out, and it's not quite completed, but what we've really got to focus on is what is going on here, okay? So we've certainly got to complete this part. This carbon is dealt with, it's got its 4 bonds there, but what the skeletal formula doesn't show is the fact that there's a hydrogen here. And that's really important, because remember our rules, we're concerned with how many alkyl groups and how many hydrogens are involved, okay? So let's see what happens. The best way to think of it is this bond gets broken, okay? Now this carbon here is bonded to 1 hydrogen and 1 alkyl group, okay? I'll draw in the hydrogens there, just so we're not confused. So what happens if you've got 1 hydrogen and 1 alkyl group? Well, let's just check. 1 hydrogen, 1 alkyl group, then we're going to form a carboxylic acid, okay? So this side is going to form a carboxylic acid. This side here is bonded to, this carbon here in the double bond is bonded to 2 alkyl groups, okay? It's got 1 alkyl group here, and it's got 1 alkyl group effectively here, okay? Right, and we're also missing a bond here, aren't we? So we can whack that in there. We've got hydrogen missing. So let's break that and let's start to draw it out. This is probably going to be very messy. I'm going to start across here, okay? So this carbon I know now is going to be forming a ketone because there are 2 alkyl groups. Go back to the rules. 2 alkyl groups, we're forming a ketone. So ketone is going to look a little bit like this, isn't it? So we've got that, that's this one up here, that's this one here is this one here, go across here, and we've got our side chain on here, haven't we? We've got our methyl side chain, which is accounting for this here. Now as we continue, we're on to this one here. Okay, make sure we put these bonds in. I know it's very slow, sorry, it's just I'm doing this all with the mouse. Okay, so we've just done this one here, we're now on to this one here. Again, 2 hydrogens there. And then we're on to our other carbon that was involved with the double bond. And we said here, because of the fact that it's got 1 hydrogen and 1 alkyl group, this is going to form a carboxylic acid. So quite simply, we've just basically replaced the double bond that we've effectively broken here. And we're going to put that a double bond with oxygen, and then our oxygen and our hydrogen to make our carboxylic acid. Okay, so I've drawn this out in a much more full version that they've shown in the answer. But if we go to our answer here, I have just effectively drawn in this, and I'll copy it across just so we can see that clearly. Okay, so I've tried to get everything on the page now. You can see now that this skeletal formula here is identical to what I've drawn here. We've got our carboxylic acid group on this side, we've got our ketone on this side, we've got the methyl side chain up here. I've got it pointing upwards, they've got it pointing downwards, but as you know, that makes no difference. Okay, so there we go, basically skeletal formula. Then we've drawn it out. Then we've made sure we know our rules about what happens, what is formed, depending on the number of hydrogens bonded to the carbons involved in the double bond. And then all I've done is basically kind of unraveled this cyclic compound. Okay, and when I unraveled it with my ketone here, and my carboxylic acid here, as I unravel it, then we're going to form this formula here. Okay, so that's how I worked it out. Hope that has helped.